Okay, go. Go and shoot something else, quick. Quick, quick, there's another 3 things. You need to shoot them down. Go. Quick. Right, go and shoot the last one.
Hello everyone, this is a short video on how we can use a simple toy to help develop the young Scottish physicist. You might be thinking, well, son is only 3, give him a chance, he's not even at school yet. You want to start developing him as a young Scottish physicist. Well, I'll grant you, what we can ask Sonny to think about, and what we can ask Sonny to do, and what we can ask Sonny to plan and carry out is rather limited. But the toy is useful to him, because he's observing motion. He's observing how things move on Earth. That's excellent for his development, necessary for his development, and ultimately will keep him safe. But when he observes this, and he eventually goes to school, he'll go what he's learned, which is considerable, from playing his games, to take things further in a more formal way. Now, I'm thinking of the child, maybe 7 or 8. And I don't think much older than 7 or 8, although I might be proven wrong. However, so when you've got a child 7 or 8, probably 3, and that child knows how to use a stopwatch, and he knows that time is measured in seconds. He knows how to use a ruler for length, and he knows that the length of things is measured in centimeters and meters, and he knows how to measure the mass of things. The mass is measured in grams and kilograms. If he knows all these things, and she knows all these things, he is ready to do this activity, whatever age that happens to be. But whenever they're at the right age for doing an activity and learning new concepts, this is the age they need to do it, not 3 or 4 years later. They have to do it when they're ready to do it. That's the only way the only way education works. You learn things when you're ready to learn these things, not too late or too early. Now, so we show them the toy. But what do we ask them? We can ask them this. The obvious question that physicists would ask: what can we measure here? After some prompting, some help, the children will eventually see all sorts of different things. But they'll eventually say, if they're ready for the activity, they'll eventually say, we can measure how far the car travelled before it stopped, using a ruler, measure in centimetres, or a measuring tape. We can measure how long it took the car to travel that distance, using a stop clock, measure in seconds. And we can measure the mass or the weight of the car, how heavy it is, using a weighing machine, measuring grams. We can measure all these 3 different things. And when they say this, we can say to them, okay, we'll go ahead and do it. There's a device, go ahead and do it. And then put your answers in some table form and come and tell us what you've done. So they'll go ahead and do it. They go back and the tool is asked. When I've done that, that's the first step in becoming an investigative physicist. They have carried out, they've planned and carried out an activity, and they are on the way to becoming investigative physicists. Next step would be, well, okay, how do you evaluate these results? What does that mean? Well, did all the cars travel in a straight line, or did they veer to the right or to the left? And they'll, some of them did veer to the right or to the left. How do we improve that? Why did the cars travel different distances? Would you get the same result if you swapped the positions of the car? So, for example, if you took the bus that was on the left-hand side, if you put the bus on the right-hand side, do you think the bus will go further or less? And they will think about that. And they might eventually say, no, the experiment was fair because they've got the same pushing force. And you will need to you would need to introduce that term. They've got the same push or pushing force from the plungers. Therefore, the experiment was fair in that respect. And then you would need to add, well, how do you think, well, what's different about the bus? Well, why didn't it go as far? And that's you introducing, even though it's got the same force as the other ones, why didn't it go as far? And that's you introducing them to the concept of dynamics and physics. And that would be a perfectly good activity that can be done at home with supervision of parents. Fine. Now, when it comes to the things moving vertically upwards, where you can ask the exact same things and evaluate it in the exact same way, although carrying out the activity and measuring these different things, especially the time, might be a wee bit more difficult because it's so quick. But that's something they have to overcome. That's something they need to think about and something you can help them with. Now, this activity here, this toy here, can be used to introduce even more complex physics concepts, all the way up to space here. And I might do that in a different video. But for the purposes of this video, that will be enough. But any parent at home who's got a toy like this can essentially use it for helping to develop the young Scottish physicists. Because the parents abroad understand the concept better than we do, and the teachers abroad understand the concept better than we do, they will produce better physicists than we can in the years to come. Of that, you can be guaranteed.
Go. Go and shoot something else, quick. Quick, quick, there's another 3 things, you need to shoot them down, go. Quick.